In this section, we want to do a little bit of work with exponential functions, and let's look at some problems that involve finding the value of an exponential function. If f of x is 3 to the x and g of x is 1/2 to the x, let's find g of 0. So I'll do that by simply substituting 0 for x in the function g. So I'll have 1/2 raised to the 0 power, and I know that that's the number 1. So g of 0 turns out to be 1. Let's find f of -3. I'll do that by going to the function f and substituting for x, -3. So I'll have 3 raised to the -3 power. That's going to be 1 over 3 to the positive 3 power, and 3 to the 3rd power is 27, so that would be 1/27. So exponential functions work just like regular functions, and when I want to find the value of the function here, I just replace x with that value and simplify. Let's look at one more of these problems. I have f of 2 plus g of -2. Well, f is 3 to the x, so I'll make this 3 to the 2, plus g of -2 is going to be 1/2 to the -2nd power. So I have 3 to the 2 plus 1/2 to the -2. 3 squared is 9. 1/2 to the -2, well, if I square 1/2, I get 1/4, and then I take the reciprocal of that, I get 4. So I end up with 9 plus 4, and 9 plus 4 is 13. So that's f of 2 plus g of -2, and I simply substitute for my variable x in the expressions for f and g and simplify what I get. Next, let's look at the graph of an exponential function. We have y equal 2 to the x for our exponential function. I want to find the graph of this. Let's first go through and make a table of values. When x is -2, I have y equal 2 to the -2. 2 to the -2 is going to be 1 over 2 squared, which will be 1/4. When I put x equal -1 in, I have 2 to the -1, which is 1/2. When I substitute in 0 for x, I have 2 to the 0, which is 1. When I substitute in 1, I have 2 to the 1, which is 2. And when I substitute in 2, I have 2 to the 2, which is 4. So let's graph the ordered pair -2, 1/4. So I'll go back 2 and up 1/4. X equal -1, y equal 1/2. So -1, 1/2. X equals 0, y equal 1. So 0, 1. X equal 1, y equal 2. So 1, 2. And x equal 2, y equal 4. 2, 4. And you can see that if I was to go further here, if I said let x be equal to 3, y would be equal to 8, x equal 4, 2 to the 4th is 16, so on and so forth. So now I'll connect these points with a nice smooth curve, and what I get is the graph of the exponential function y equal 2 to the x. And you can see it goes to the point 0, 1 on the x-axis. All exponential functions will go through that point, on the y-axis, 0, 1. Let's look at one more problem. We want to graph the exponential function y equal 3 to the x and its inverse. So first, let's graph y equal 3 to the x. When x is 0, y will be 1. When x is 1, y will be 1, 2, 3. That's 3 to the 1. When x is 2, y will be 3, 4, 5, 6, 7, 8, 9. When x is -1, y will be 1/3. When x is -2, y will be 1/9. So I can sketch the graph of that exponential function y equal 3 to the x real quickly, just like that. Now, the equation of its inverse is x equal 3 to the y. To find the equation of the inverse from the function itself, I simply exchange x and y. Now, I could graph that myself separately, or I can use the fact that the graph of a function and its inverse have symmetry about the line y equal x. So I'll draw on the line y equal x. Looks like this. Of course, this would be much nicer on graph paper. Now I'll reflect my graph of y equal 3 to the x about the line y equal x, and I'll have this point. When x is 1, when y is 1, x will be 3. When y is 2, x will be 9. When y is -1, x will be 1/3, 1/9, so on and so forth. All those ordered pairs have their coordinates reversed. And so here is the graph of x equal 3 to the y, which is the inverse function for this function, this exponential function, y equal 3 to the x. So graphing a function and its inverse is pretty easy if we know the graph of the function. We simply take that graph and reflect it about the line y equal x to get the graph of the inverse. Finding the equation of the inverse from the equation of the function is also easy. We simply exchange x and y.